In this video 4 or 5, we are going to be looking at similarity transformations. By the end of the video and work time in class, you should be able to say, I can graph dilations. A dilation is a transformation where a figure and its image are similar. A scale factor is a ratio of the corresponding lengths. An enlargement is when this scale factor is greater than 1. And a reduction of an image is when the scale factor is less than 1. Here you can see some different dilations. For example, from center in the corner here with the tigers, you can see the original versus the dilation as it gets bigger. They are the same shape, but they're different in size. We're going to use that method here shortly, or a method similar to that, to enlarge a triangle. You can see too with the stars, the purple and the lighter purple, you have a bigger image of the smaller star. That's that lighter kind of pink purple color. You can also see here a map is where we use reductions. If we're looking at like a Google map or something, you can see we're looking at the grounds of like an athletic complex. It looks like maybe of a high school or a college, where you can see the baseball diamonds and tennis courts, pools, and football fields and all sorts of things here. The building too. And so we can see that it's scaled down to size so we can see a bigger picture in the smaller area. It looks like the real thing, it's just smaller. It's all in proportion. So you look at the tigers at the top, they're in proportion to each other. The stars are in proportion. They look the same, they're just different in size. Same with the map. So we use dilations all of the time. In this first example, we're going to find the image of triangle ABC after a dilation with center A and the scale factor of 3. So if it has a scale factor of 3, it's going to enlarge. It's going to triple in size, actually. So I'm going to draw a triangle here. And I'm going to say that this is A, this is B, and this is C. And I'm going to say this distance here is 3, and we'll say this is 2. So if I'm going to enlarge from A, center A, and if I'm enlarging A to C is 3, I'm going to go another 3 to double the size, and about another 3 to triple the size. So this is an estimate of taking that side and tripling it. If I say this is 2 from here to here, if I double, I'm about here. If I triple, I'm about here. I'm just basically enlarging the sides here by just looking. It's kind of, like I said, it's an estimate. And then from here, the last side, I would just connect. And that is approximately tripled in size. So this is my new A prime. This is my new C, so C prime. And this is my new B, that would be B prime. So it tripled in size, the blue triangle to the green, blue and green, I guess I should say. Another way to make a dilation is actually on a coordinate grid. In this one, we're going to have a scale factor of 1/2, so it means it's going to be a reduction. So what we're going to do is we're going to take all 4 points here, we're going to graph them. I'm going to use my blue marker here and graph each point. So here's K, 0, 2, here's L, 4, 2, M, and 4, -1. And so here's K, L, M, and N. And so I'm going to connect. And with a reduction, it's kind of down here. My smartboard's not accurate right here right now. Now with the reduction, it's going to get smaller. So what we do here is we take each point and we multiply the coordinate by 1/2. So K prime, we're going to take -2, multiply it by 1/2. 1/2. 1/2 of -2 is -1. 1/2 of -1 would be -1/2. So that's where K prime will be. L prime, half of 0, 0. Half of 2 is 1. For M prime, half of 4 is 2 and half of 2 is 1. And for N prime, half of 4 is 2 and half of negative 1 is negative 1 half. So now we're going to plot these 4 points, negative 1 half. And we've got 0, 1. We have 2, 1 and 2, negative 1 half. And so we can see, oh, let's see here, take that back. We can see the reduction. My smartboard is definitely off right here, kind of at an angle. And so this isn't going to be accurate with the smartboard here, where the K is now. That line is angled, but it should be a little bit straighter there. So you can see here we reduced the size by 1/2. So now we saw one more of an estimate and an enlargement. You could also do a reduction estimate similar to what we did here. And this one is a reduction on the coordinate grid. Can you say I can graph dilations? Here's your output to work out and be prepared with any questions for the work time in class.